Atoms don't stay atoms for long. Their outermost electron shells do not have a stable octet configuration, and thus they have a tendency to either shed electrons to become positive cations or gain electrons to become negative anions. As cations and anions have opposite charges and opposites attract, they attract. This bonding is known as ionic bonding. Unfortunately, we do not know which atom each electron belongs to in the Bohr model, so we'll need a new model, the Lewis dot structure, which is just like the Bohr model, except that you now know which electron belongs to which atom. Oh, and you're not required to draw the inner electron shells. Convenience. Back to ionic bonding. The soon-to-be cation atom loses an electron, which is taken up by the soon-to-be anion atom. The ions now possess opposite charges and attract. In ionic bonding, all the electrons lost by cations must be gained by anions, regardless of the resultant charges of the ions. The ions are tightly packed together in a lattice structure, with strong forces of attraction between the ions, which require a lot of heat energy to overcome. As such, ionic molecules have high melting and boiling points. But what about bonding between atoms that would become anions? Ionic bonding between them is impossible as the anions are more likely to gain electrons than lose them. Even if ionic bonding does occur, your oxygen would not be O2, but O4. Or is it OO3? Instead of ionic bonding where electrons are transferred, these atoms form molecules by covalent bonding where electrons are shared. In the process of sharing electrons, each individual atom now has a stable octet structure, with the shared electrons in the overlapping region forming the covalent bond. A simplified version of the Lewis dot structure can be used for covalent bonds, with unpaired electrons drawn and shared electrons drawn as lines, with one line representing a pair of shared electrons. In a molecular model, the unpaired electrons are not needed. While the intramolecular forces of attraction are strong and difficult to overcome with physical means, the intermolecular forces of attraction, known as van der Waals forces, are weak and can be easily overcome with heat energy, giving covalent molecules low melting and boiling points. What then about metals? Their bonding has a straightforward name: metallic. In metallic bonding, metal atoms lose their electrons and the cations are closely packed together in a sea of delocalized electrons. The cations have strong forces of attraction amongst them and the delocalized electrons. This gives metals a high melting and boiling point.